Alright, in this video we're going to be talking about the difference between a scalar quantity and a vector quantity, and we're going to be given an example of a scalar and a vector in the form of distance and displacement. So let's talk about these things. So what is a scalar quantity? A scalar quantity, it just has a magnitude. And what we mean by that is it's just measuring the size of something. So maybe a scalar quantity would be how tall is some building or how fast were you running. But then what we have, let's get a little divider. We also have vector quantities. So what is a vector? A vector, in essence, it does have magnitude. So it still has magnitude, but it also has a direction attached to it. A direction attached to it. Okay, so let's discuss an example of this to really get into the details of what the difference between these two things is. So we're going to talk about the difference here between the quantities of distance and displacement. So over here we're going to have distance, and over here we're going to have displacement. Displacement. Okay, so distance we're just going to define like this. We're just going to say if you're measuring, say something is moving and you measure its distance, it's a little bit self-explanatory. It's just going to be the total distance traveled. The total distance traveled. But with the displacement, we're going to define it this way. It's going to be the net change in position. Now that sounds like a very different definition. And while it is different, it's talking about the same thing. We're still concerned with position in both of these cases, but it's measured a little bit differently. So let's look at an example. Let's do the same example on the left and the right and talk about the difference between the distance and displacement. So let's say I'm walking in a straight line from left to right, and I walk left a little bit, but then I decide I want to turn around. So I go back in the other direction, and it might be easier to do this. So I walk to the right a little bit, and then I stop and I turn around and go the other direction, but then I turn back around and I keep going. And we'll illustrate that this way. So I just walked a little bit from left to right, traveling in this direction, but then when I got there, I turned back and I walked a little bit in this way. And then when I got a little bit farther back, I just went a little bit farther in the right. So I just walked, but then I stopped and I turned back a little bit, and then I kept going all the way to the end. Now, we just have some arrows here to denote which direction I traveled. I was not moving up or down. This is just 3 different instances of me walking in the same straight line. So we're going to say that this top one was 5 meters, and we're going to say this bottom one is 3 meters, or this middle one, excuse me, and the bottom one we'll say was 8 meters. Was 8 meters. Okay, so what's my distance? Well, my distance, and we're going to denote it by a D. So this is going to be denoted by just a D, all right? So what's my distance? Well, if my distance is my total distance traveled, that's how we're defining it, well, then it's just going to be the 5 meters that I traveled, plus the 3 meters that I traveled, plus the 8 meters that I traveled, for a total of 5 plus 3 is 8, and 8 plus 8 is 16 meters. So my distance here was 16 meters. But now let's look at displacement. So I want the exact same situation. the exact same situation over here, but now I'm going to talk about my displacement. And we're going to denote displacement by something a little different, delta x. And so the delta and the x are going to be very common notations throughout physics. The delta is just going to be change, so change, and the x is just going to be position. So total, this is just our change in position. So now let's calculate it. Well, if I started here, and we're just going to say that I started at 0, and then I moved up here, so I'll just mark this 0, and then I moved here to 5, but then I moved back 3, so if I'm at 5 and I move back 3, I'm at 2, and then I moved forward 8. So if I'm at 2 and I move forward 8, then I'm at 10. And again, remember that I'm not traveling up or down. These lines are just representing my motion in a straight line. Okay, so what's my displacement? So what's my delta x? You'll often see delta x written like this. You'll see it, if it's the change in position, then it's going to be my second position minus my first position. So just where did I end and where did I start? Well, in this case, my second position was over here. I ended at 10 meters. So I ended at 10 meters. And my first position was right here, so that's just 0. So I'll just say minus 0 meters. But that gives me 10 meters. So my displacement here was 10 meters. All right? Now, we could also have added it up this way. We could have also said delta x, or my displacement, equals, well, I went 5, and we talked about the vector quantity, but then right here, I moved backwards. I went the other direction, and so we're going to note the change in direction there by a negative. Then I went minus 3 meters, and then here, I went forward by 8 meters. So plus 8 meters. So 5 minus 3 gives me 2, plus 8 gives me 10. So it is just the net change. We took into account the direction. So up here we said that our vector has magnitude and direction, and we took that into account down here. This was just going backwards, and so we didn't add it like we did over here. We were just keeping track of our position.